In this video, I'm going to discuss a little bit about the complex numbers because we will see them in quadratic formula, and it'd be nice to kind of know what they are. So over here, right here, we have this graph. Let's say this is x, this is y. And sometimes when you graph parabolas, which is that U-looking shape, you'll notice that they won't cross the x-axis. Okay, so usually when that happens, we say, oh, well, there's no solutions. That means that there's no x-intercepts. Okay, however, this is not entirely true, at least not the way it's written. What we should be saying is that there are no real solutions. Okay, you've noticed in the past that when we talk about domain and range, especially, that we have this fancy looking R. So these are what we call the real numbers. Okay. Now the real numbers are things that we're used to, like 1 through infinity, and you actually, negative infinity to infinity, and they exist on the xy plane. Okay, so complex numbers have a different plane. So we call those ones imaginary numbers, and those ones are instead of the R, it kind of looks like a fancy C, kind of like this, I believe. So without going into too much detail, it's pretty much like a different number system. Think of it as an alternate universe, okay? The polar opposite of real numbers. Okay. So anyway, what that looks like is something like this. On a graph, our imaginary numbers are actually like these little roots right here. So I guess what you would consider the x-intercepts, but they don't exist on this plane, they exist on, the complex plane. So anyway, let's go ahead and talk about the math part. If you didn't get this part, that's okay. Complex numbers are an entirely different lesson, and we are not going to get too much into them, but we do need them to solve certain problems. So let's go ahead and do some notations here. Okay, complex numbers, also known as imaginary numbers, okay, are denoted with an I. Okay, I for imaginary. And there is this little, I guess you could say, formula that we use for them that looks like this. So pretty much whenever you have a negative inside a square root, it's the equivalent of one imaginary number. So for example, let's say we had the square root of -4. Okay. Well, if you remember your rules with square roots, this is the same as the square root of -1 times +4. So all I'm doing is I'm just separating -4 into -1 and 4, which is the equivalent of the square root of -1 times the square root of 4. Because the rules of square roots allow us to do this. We can break this up because it's just multiplication. So what would happen in this case is this right here would be the same as an I, because the square root of -1 is just I, and we know the square root of 4 is just 2. So my answer would look like this, 2I, which means that our answer is not a real number, but an imaginary one, equivalent to 2I. Okay? So let's try a couple more and just see if you kind of get the hang of it. So let's say we have, I don't know, the square root of -12. Okay? Well, from my old notes, I know that this is 3 times 4, and then that's 2 times 2. And then I have that negative. So remember that negative is the same as that little -1. So I'm going to rewrite this now as the square root of -1 times 3 times 2 times another 2. And I'm going to start simplifying this. So I know also from the past that these ones right here are a pair, so they get taken out. So I have a 2 on the outside, and I also know that this -1 is the same as my I, so I have an I on the outside, and I'm left with just that 3 on the inside, this 3. So I have, sorry, that should not be an equal sign. I have a 3 here. And this would be my simplified version of this particular problem, okay? So pretty much what we're doing here is we're combining something we've done before, simplifying radical expressions, which was all this number business here, and adding the I component, the imaginary number component. So I'm going to do one more, then I'm going to change it up a bit. Remember, all we're kind of doing is exploring this little I thing. So let's say we have, I don't know, let's say we have 3 plus I times, we'll say 7 plus I again. Okay, so this is a FOIL problem, and again, we're just applying that little I to different scenarios. So we would distribute, so 3 times 7 would be 21. 3 times I would be plus 3I. And then we would take care of the other side. So I times 7 is plus 7I. And I times I is plus I squared. Okay, so this one kind of leads into something interesting. Let's go ahead and combine this first, and we'll get to that part. So 3i's plus 7i's is 10I. And bring down that 21. Bring down that I squared. Let me write that a little bit better. And you'll notice that this one doesn't have any kind of square root. However, it does have an I squared. So I can actually do something with that. To understand that, though, I'm going to have to go up, back up to the top and kind of show you something. So here, right here, with this information, if I were to square both sides, and I'm going to erase this in a bit, if I were to square this one and square this one, what I would get is I would get -1, because this would cancel, right, is equal to I squared, which gives me another little formula I can kind of use. Okay, -1, if I ever get an I squared, it's the same as that I squared. So let me go ahead and go down. I didn't erase it, that's okay. And I have an I squared right here. So according to my little formula, -1 is equal to I squared. This is the same as -1. So now I have 21 plus 10I minus 1, because this I squared, again, is the same as -1. And I can go ahead and combine some more stuff here. So I have 21 and -I, which would give me 20. So my final answer on this one would be 10I plus 20, because 21 minus 1 is just 20. And this is my simplified answer for this multiplication here. Okay, so just a few applications of I, which again represents the imaginary numbers. These are numbers also known as the complex numbers. They do not belong on our real number plane. So, you know, we have this other symbol, okay? And again, this business over here, if you didn't really get it, that's not a big deal. I was kind of trying to simplify it, you know, for time purposes. But what you do need to take from here is that this right here, -1, square root of -1 is equal to I, and I squared is equal to -1, okay? And that's it. We should be able to solve some of the quadratic formula problems now.